In fundamentals of organic chemistry, today we are going to see the purification of organic compound. Why we have to purify that organic compound means we have to study the structure, physical property, chemical property and biological property. For that reason, we need a pure compound. But organic compound containing some impurities means we can't study the structure, physical and chemical property, biological property in a correct form. So that we have to purify that organic compound. The solid organic compound, they are purified by three techniques. They are sublimation, crystallization, fractional crystallization. So these three techniques for solid organic compound to purify that organic compound. The next one, suppose the organic compounds are liquid means the following techniques are used to purify that organic compound. One is distillation, fractional distillation, steam distillation, distillation under reduced pressure, azeotropic distillation, differential extraction, chromatography. These techniques is only for liquid organic compounds. Rest of the lesson in PPT. I already told in introduction part why we have to purify this organic compound means we have to study the structure, physical property, chemical property and biological properties of organic compound. So we need the organic compound in a pure state, then only we have to study these above this, and then we have so many techniques to purify that organic compound, but the techniques are based on the nature of impurities and nature of organic compound. So solids are purified by sublimation, crystallization, fractional crystallization. Liquids are purified by then 7 method. They are distillation, fractional distillation, steam distillation, distillation under reduced pressure, azeotropic distillation, differential extraction and chromatography. So today we are going to see these method. Sublimation process. Before going to the sublimation process, one example. For example, ice cube. Ice cube on heating, what will happen? The ice cube slowly melt and then it changes into liquid. Afterward, if you give the heat, what will happen? That liquid, air liquid into vapor state. But in this sublimation process, that substance on heating, it directly changes from solid to vapor. It never changes to solid to liquid. Afterward, liquid to vapor. It is not like that. In sublimation process, the substance on heating, it directly changes from solid state to vapor state. That is called as sublimation process. So in this sublimation process, we are use the volatile. Volatile means what? It is a vaporable one. Volatile meaning vaporable one, and we are separating the volatile substance from non-volatile solid. Non-volatile means it is not vaporable one. So impurities may be a non-volatile and organic substance is a volatile one. So we can separate the organic substance from non-volatile, volatile organic substance from non-volatile impurity based on this sublimation process. Then in this right hand side, you see that in blue color I underlined that organic substance which possesses high vapor pressure at temperature below its melting point, that substance we can use this sublimation process. So what are the substances we are using here means benzoic acid, naphthalene and camphor. And some substance, the vapor pressure, which one having a small vapor pressure, that substance we can't use it because they decompose on heating. So that substance we can sublimate with the help of under reduced pressure. We have to reduce the pressure. Afterward only we can use this sublimation process for the substance which one having a small vapor pressure. Then you see the diagram. In the diagram, the inverted funnel is used. That a China dish, it has the organic substance along with the impurity. When on heating, that organic substance alone, it is a volatile, so vaporable. It goes to vapor state. That vapor on cooling. Cooling means where it is cooling means the inverted funnel. There is a large tube-like structure, Noma. That tube structure cooling will be happen. So here only we are getting the pure substance. Afterward we scratch the side of the funnel, we get the pure substance. In this one, that inverter funnel, the bottom of the inverter funnel, there is a large area for heating, but that cooling area, that is a tube like a structure noma in that funnel, it is a large cooling surface area but with a small distance. Why it is a small distance means, because the amount of substance in the vapor phase, it is too small when it is a low vapor pressure. The substance which is having a low vapor pressure, that substance amount is very small when it is in a vapor phase, so that it had the large heating and then large cooling surface with a small distance in between that. Okay guys. Next method is crystallization process. In that process we have 5 steps. First of all, we have to choose the solvent. Which solvent is used to dissolve the organic substance. Organic substance is a covalent compound, so that covalent solvent compound alone uses a solvent. So we have to choose the solvent first. The next one, preparation of hot solution by dissolving the organic compound with the solvent. We first select the solvent noma. In that solvent, the organic compound is dissolved on heating, so that we are getting the hot solution. So this is the second step. And third step, it is a filtration step. In that filtration, the impurities that is not dissolved in solvent, that impurity we can separate with the help of filter paper. And then fourth step, it is a crystallization process step. In that step, just we are going to stay that filtrate as it is. That is called as crystallization step. And fifth step, in the crystal, it is formed on the liquid, above the liquid. That crystal we can separate with another funnel. We will see later. That step is called as isolation and drying. So there are 5 steps in crystallization process. In crystallization, the first step is selection of solvent. We know the organic substances are covalent compounds. So covalent compound, they do not dissolve in water, because water is a polar solvent. So polar solvent dissolve the inorganic compound only. We are studying now organic substance. Organic substances are covalent compounds, so that they dissolve only in the covalent compounds like solvent. Then we have to choose the solvent. That how can we choose means, just you add the organic compound, what we are having, that organic compound just dissolve in that solvent. It is not dissolve means just stirring and then heating. If the solid dissolve on heating means, it throws a maximum amount of crystals on cooling. So that solvent is a suitable solvent. Now that what are the solvent we can use it for crystallization process means, they are benzene, ether, acetone and alcohol. They can be used as a solvent for organic compound. Next step is preparation of solution. The solution is prepared with the help of solvent. Suitable solvent we already choose noma. That suitable solvent is added with the organic compound. Now that suppose that organic compound is a colored one, that colored we can remove with the help of animal charcoal. Now the heating will be done with the help of wire cage. When we use this wire cage means, the solvent, it is having a low boiling point, means it is safe to use the wire cage. Then otherwise, the solvent having high boiling point means it is high risk, so that we have to heat the organic compound with the solvent in the water bath. Water bath means nothing but a bowl with water. On heating, it gives that boiling water. In that boiling water, we are going to heat. We don't give the heat directly to the organic compound, because the solvent is having the high boiling point. So that only we are using that water bath. The next one, filtration. Now that impurity alone not dissolve in solvent, the organic compound is dissolved in organic solvent. That impurity never dissolve in that we have to remove that impurity with the help of fluted filter paper. We already saw that diagram in the previous slide. Please refer that one. Now we get the filtrate. that here I show one diagram. In that beaker, that filtrate is having the brown color is the filtrate ma. If you keep this hot filtrate is allowed to cool in a room temperature, slowly above the liquid pot, crystal will be formed. I saw that in orange color. Not all the crystals are in orange color, just for example I showed here ma. So a crystal will be formed on the liquid pot. That liquid pot is called as mother liquor. Don't confuse with that what is like mother liquor. The filtrate, when you allowed it to cool, that liquid pot, above that liquid pot crystal will be formed, no. So the bottom of the liquid pot now called as mother liquor. Now the crystallization we obtain, no. Suppose the crystals not formed, the rate of the crystallization is very slow, means that time we have to scratch the walls of the beaker with a glass rod. With the help of glass rod, just scratches the sides of the wall of the beaker. Why we are doing means we are disturbing the molecule, disturbing the liquid, because it is not forming the crystal. If you disturb the water molecule means that filtrate, the automatically the crystal will be formed. Or otherwise we can use another method by adding a few crystals. That crystal also, with the help of crystals, the crystallization process will be will begin. The next one, isolation. Now the crystal formed, noma, we have to separate the crystal from the mother liquor with the help of puncture funnel. That it is a slow process, so that we have to do with the pressure. The next one, if we get the crystal in the puncture funnel, still it having some impurity, so we have to wash the crystal with small quantities of pure cold solvent. Then afterward we have to dry that crystal. Then only we get the pure organic compound. Distillation process. In this distillation process, we get the pure compound from the non-volatile impurity. What is volatile means? It is a vaporable. Non-volatile means it is not vaporable. So the impurity should not vaporable. That organic compound alone, it is a vaporable one. So we can separate the impurities, which that impurities nature, what the nature of impurities ma? It is a non-volatile one. That then only we can separate the liquids. Then that boiling point difference, suppose we have two more organic compound, means that boiling point, with the help of boiling point difference we can separate the organic compound in this method. In this distillation method, there is a three parts. One is distillation flask. In this distillation flask we are going to take the mixture of organic compound, and then that distillation flask fitted with the thermometer. It has some side tube. That side tube is circulated with the cooling water. That side tube circulated cooling water is called as condenser. So it is a second part. And that third part is a reservoir part. Reservoir part means that first of all that liquid is heated. The liquid is changed into vapor. That vapor, it is moved to the side tube. That side tube is called as condenser. In that one, the vapor is condensed to give the liquid. That liquid is received in the conical flask, that is called as reservoir. So there is a three part in distillation process. The distillation process, there is a three types. One is simple distillation, fractional distillation, and steam distillation. What is simple distillation means? I already told that difference in boiling point is the main is for the distillation process. Suppose the boiling point difference is above 40 Kelvin, means we can use the simple distillation process. Then that compound should not be decomposed and then under ordinary pressure. These two condition it is satisfied, means we can use this simple distillation process. What is the condition? Two condition. One is the boiling point difference should be above about 40 Kelvin, and that compound they do not decompose under ordinary pressure. These two conditions satisfied, means we can use the simple distillation process to separate the organic compound. For example, C6H5NO2, that is name is nitrobenzene, that boiling point given as 484 Kelvin, and then C6H6 benzene, then boiling point is 354 Kelvin. The difference is above 40 Kelvin, so that we can use the simple distillation process. On heating, which one is come first? The benzene boiling point is 354, so it will come first. On vapor, afterward cooling, we get the benzene first. The next one, when it reaches the boiling heating 484 Kelvin, then only the nitrobenzene will form as a vapor. That time we can cool, means we get the nitrobenzene separately. The same way in diethyl ether, the boiling point is 308 Kelvin, and ethyl alcohol boiling point is 351 Kelvin. So this one also, the boiling point difference is 40 Kelvin above, and then we can use the simple distillation process. We can separate these two compound as separate one. Fractional distillation, it is nothing but the same distillation process only. Here also we are going to heat, give the heat to the liquid organic compound, that a boiling point difference, with the help of boiling point difference, which one having the boiling point is small, that is enter into the vapor phase. After cooling, that vapor is cooled as a liquid. The same method is here, but what the difference between simple distillation and fractional distillation is? In simple distillation, the boiling point difference is 40 Kelvin and above, but here in fractional distillation, the boiling point is very close to each other. So that time we have to use the fractionating column. You see the diagram, in that one, the conical flask, the distillation flask, it is fitted with the fractionating column. That fractionating column is it is attached with the side tube. That side tube is called surrounded by the cooling water, so it is a condenser pot. That condenser pot is now joined with the reservoir. So this fractionating column, why we are using fractionating column means, because the boiling point is very close to each other. So we very close to each other means, when one compound is reach the boiling point, that another compound also at the time, at the same time it reaches its boiling point. So that it come both of at the same time, we can get that at reservoir. So avoid that one, we are using fractionating column. In this fractional distillation, we can use it for petroleum, coal tar and crude oil separation. The main difference between the simple distillation and fractional distillation: simple distillation containing 3 parts, distillation flask, condenser, reservoir. But in fractional distillation, it contains 4 parts, distillation flask, fractionating column, condenser and reservoir. So 4 parts. Steam distillation. This distillation process is suitable for both the solid and the liquid. That it should not decompose. Which one? The organic compound should not decompose at steam temperature. When the steam is passed through the organic compound, that organic compound should not decompose. For example, benzene formula C6H6. When the steam is passed through it, I have to get the benzene as it is, that is C6H6 means C6H6 I need, but on heating it decomposes, means the carbon and hydrogen separated, then I get the carbon separately and hydrogen separately. It is not like that. So that what is the condition first? Means the organic compound, they should not decompose at steam temperature. The next one, the vapor pressure of the organic compound at 373 Kelvin, it should be a high one. 373 Kelvin means the boiling point of water. Why here boiling point of water is mentioned? Means steam. What is steam? How can you get the steam? Steam from the water only. When the water is boiled, it gives the steam. So boiling point of water is 373 Kelvin. At that 373 Kelvin, the organic compound vapor pressure should be a high one. This is the second condition. And third condition, the organic compound, they should not be soluble in water, because if it is soluble in water means again it is going to vapor state. Afterward, along with the water only we can get the organic compound, so that it should not dissolve in water. The next one, the impurities should not be a non-volatile one, should be a non-volatile one, because non-volatile means it is a non-vaporable. If it is vaporable means along with the organic compound it goes to condenser pot. Afterward in reservoir we get the impurities with the organic compound. So that impurities should be a non-volatile one. So that we have four condition for steam distillation. Here that we already know that in simple distillation three parts only, but here one more part, because we have to produce the steam. How can you produce the steam? With help of water. So that one more flask is given. In that first flask it has the water on heating it gives the steam. That steam is passed through the distillation flask. The distillation flask is a slanting position, because the no droplets of mixture will enter into the condenser. So on the brisk boiling and bubbling of the steam, when the steam is passed through that distillation flask, some bubbles will be produced. That bubbles should not be enter into the condenser, so that only the distillation flask it is maintained in the slanting position. Afterward, now that steam already that distillation flask it is giving the heat. You see the diagram, distillation flask also we are giving the heat. The same way the steam it is also having some heat. So both the heated the organic compound, so that the organic compound reaches the boiling point very easily or very quickly. So then we get the organic compound in pure state very fast. Then in this method we can separate the oil from plant and flour. To have to manufacture the aniline and turpentine oil, we can use this steam distillation process. In this azeotropic distillation, the mixture of liquid cannot be separated by fractional distillation, because see the example. In that example, 95.63 percentage ethanol is mixed with 4.37 percentage water. Here it boils at 78.2 degrees Celsius. That is, ethanol boil at 78.4 degrees Celsius, but water boils at 100 degrees Celsius. Both are present in mixture. Even though both are present but they boiled at a constant temperature, that is 78.2 degrees Celsius. So in this temperature, both the component has become as a single component at this fixed temperature. Fixed temperature means 78.2 degrees Celsius. Both the one will distillate, but we need any one. So for that we have to add third component. Here first of all we have two components. What are they? Means ethanol and water. But that ethanol and water together it is distilled but we need any one compound. So we have to suppress any one boiling point of one component. For that we have to add third component, either benzene, carbon tetrachloride, ether, glycerol and glycol. What they will do means they depress the partial pressure of one component in the azeotropic mixture. For the example, we have taken that what is azeotropic mixture here means ethanol and water, that it has two component. Then the two component boils at the temperature 78.2 degrees Celsius, but in this temperature we get to both the component, but we need only one component. Means we have to add third component. That third component they depress the partial pressure of one component and rises the boiling point of another component. That another component will distill now. For example, then the dehydrating agent, what are they? Benzene, carbon tetrachloride, ether, glycerol, glycol. But in this one, the benzene and carbon tetrachloride, both the one having low boiling point. So they reduce the partial pressure of alcohol. And then suppose we are adding glycerol and glycol, means they have high boiling point. So they reduce the partial pressure of water. So wherever we need, suppose you want to distill over the ethyl alcohol, means we have to add third component which component means that benzene and carbon tetrachloride we have to add. Then we have to reduce the partial pressure of water means we have to add glycerol and glycol with that azeotropic mixture. Then only we can distillate only one component. So to distillate only one component in the mixture, we need third component to suppress the boiling point of that another component. Differential extraction. Aqueous solution. What is the meaning of aqueous? Aqueous means water. The organic compound containing water. Water never dissolve the organic compound because organic compound is a covalent compound. Covalent compound dissolve only covalent compound alone. But water is a polar solvent. In that polar solvent, organic compound never dissolve. So in that aqueous solution, that organic compound not dissolve. So we have to add another organic solvent to dissolve the organic compound. So it has two layer ma. One is aqueous layer, that aqueous layer containing organic compound, and then solvent layer containing only solvent alone. What solvent? Organic solvent. So see the diagram here, that we are one apparatus we are taking. That apparatus name is separating funnel. In that funnel, the yellow color layer is solvent layer, then blue color layer is aqueous layer. That aqueous layer containing organic compound, but organic compound not dissolve in aqueous layer ma. Then after shaking, what happening there means that organic compound goes to solvent layer. That solvent layer, that organic compound now dissolve. Then in aqueous layer there is no organic compound. That aqueous layer now containing only impurities. Now opening that nab of the separating funnel, we can separate the aqueous layer alone. Then now that our solvent layer containing organic compound, we can distillate that one, we can get the organic compound separately. Here that separating funnel, that organic solvent layer what we are having, no ether or chloroform shall we add here. That organic solvent immiscible with water. Immiscible means they never dissolve with the water, so they form the separate layer. What layer means, you see that the after extraction there is a green color layer and then blue color layer. Green color layer is a solvent layer, blue color layer is a aqueous layer. So we can separate the impurities and then organic compound from the use of this solvent extraction. That is called as differential extraction. Chromatography. Chromo means color. Graphy means writing. So based on the color, we are going to separate the organic compound. This chromatography is used to separate or purification of the even a small quantity of organic compound. This method is developed by M.S. Stewart by using the when he is a botanist. He examined to what are the elements present in the chlorophyll. So he conducted one test. In that test, he first placed the leaves in the petroleum ether solution. So we get the one solution. That solution, it is passed through the one narrow column glass tube. It is packed with the calcium carbonate. See the diagram. One glass tube is a calcium carbonate is packed ma. In that narrow column, the petroleum leaves in petroleum ether solution is we are passed means we get some different colored zone. That is the zone containing the different elements that is present in the chlorophyll. The leaves containing chlorophyll we know very well. So he separated the elements that is present in the chlorophyll by conducting this test. So this is the basics for the chromatography. So this test like this we are doing some kinds of test to separate or purify the organic compound. So this technique is called as chromatography because we are getting different colors. Based on the colors we are separating the elements. So it is called as chromatography. Here, the leave in petroleum ether is a moving phase. Why it is moving phase means that liquid is passed through the calcium carbonate. But the calcium carbonate is here called as a stationary phase because it is never move. That is, it remains in one place. So it is called a stationary phase. So in chromatography, we are having two phases. One is stationary phase, another one is moving phase. Principle behind chromatography. There are two phases we are studied now. One is stationary phase and another one is moving phase. Between these two phases, the organic substances are selectively distributed. That is the principle behind in the chromatography. Then stationary phase. Which one are active stationary phase means solid or liquid. The both the one, the solid is a stationary phase because it is remains in one place. The liquid with the support of solid only, liquid it remains in one place. For example, in water bottle, with the support of bottle only, the liquids are remains in one place. So stationary which are act as a stationary phase means the solid and then liquid both the one act as a stationary phase. Then moving phase, which one is moving? The liquid and then gas. So liquid or gas both the one we can use as a moving phase. Then if a stationary phase is a solid means the basis of separation is called as adsorption. Then the stationary phase is a liquid means the basis of separation is called as partition. So adsorption it is take place when the stationary phase is solid. The partition is take place when the stationary phase is liquid. Then now definition for chromatography, it is a separation of mixture it is brought about by differential movement of individual compound through the porous medium under the influence of moving solvent. That is, we already see that in petroleum ether solution it is a moving phase. In that one it contains some components. That components are separated when it moves through the calcium carbonate. The calcium carbonate acts as a stationary phase. So that with the help of stationary phase and moving phase only, we are going to separate the organic compound. That is the principle behind in the chromatography. Adsorption chromatography. What is the meaning of adsorption? Adsorption means it is fixed on the surface of substance. That substance called as adsorbent. Adsorption means it is a just fixing off on the surface or sticking means glue. Just you see the glue means what is happening. If you place the glue on the surface of any paper or any substance means that glue attract the another substance. That is the adsorption means don't confuse with the absorption means that whatever substance placed in the surface, that surface that is not attached on the surface alone, they will mingle with the inside of the substance. That is called as absorption. For example, water with the sponge, what will happen? Sponge will absorb all the water. But if you put the glue, what will happen? The glue is just rest on the surface, just it is stick on the surface of the substance. That is called as adsorption. Now we understand the adsorption, I think. Now based on this adsorption chromatography means, for example, you see the diagram. In the diagram, first of all, the green color, that green color means it is a mixture of compound X and Y. That mixture is placed on the silica or alumina. Here the silica and alumina are adsorbent. In the adsorbent, it adsorbs the X and Y in different rate. Y is very fastly adsorbed, so it moves down, and then X is it adsorb very slowly, so it takes time to adsorb. Then with the help of solvent, afterward we put the solvent means it moves the Y very fastly because it adsorbs very fast, it comes down first. Afterward the X component, it is adsorbed in the silica or aluminoma, that is washed by that solvent. So based on this adsorption we can separate the compound which are present in the mixture. Column chromatography. In that column chromatography you can understand with the help of the diagram. See the first diagram, the narrow column glass tube, it is packed with the stationary phase. Which are all active stationary phase means activated aluminum oxide, that is alumina, magnesium oxide, starch. They can act as a stationary phase. You have to pack that narrow column either of this compound. Then the narrow column bottom, it containing stopcock. That's with the help of stopcock only we are going to separate the compound. Before packing the adsorbent powder, that cotton or glass wool is placed at the lower end of the column to give the support to the adsorbent powder. After uniform packing with the adsorbent powder, now see that second diagram. In that diagram, the mixture containing three component, that is green color component, orange color and purple color component, it is placed above the stationary phase. Afterward we are going to add some solvent. Here the solvent name is called as eluent. If the solvent is added means which one is adsorbed by the adsorbent is fastly moves to the lower end. Now the purple color is adsorbed very fast by that adsorbent, so it goes to lower end. Afterward orange color the next element is green color. It is adsorbed very slowly by the adsorbent, so that it is remain at the top. Now by adding the solvent, that first the purple color is separated, it is washed so that the purple color is separated. Afterward the orange color is separated. By using the stopcock we can stop the seeing the color we can stop the compound gas. Now this solvent is added that is called as eluent. That eluted means it removed the colored compound. On seeing the color we can with the help of knob we can easily separate the compound. So column chromatography, I think with the help of diagram you can understand the column chromatography. Thin layer chromatography. In this thin layer chromatography, first of all we have to prepare the thin layer. Thin layer is act as a stationary phase. But thin layer, how can it is act as a stationary phase? It with the help of support. What support we are going to give means a sheet of glass. That glass is coated with a thin layer of adsorbent. The thin layer is not a stationary one so with the help of glass plate only it acts as a stationary phase. Here the thin layer of adsorbent what we are using here means cellulose, silica gel or alumina. That sheet of glass is now called as chromoplate or thin layer chromatography plate. In this technique we can use it is possible to separate even a minute quantity of mixture. So first of all that chromatography plate is placed after drying the plate. If that baseline, we have to draw one baseline. In that baseline only we are going to place a mixture of compound. That mixture of compound means you see the diagram. In the diagram the mixture containing red color, purple color and blue color compound. So how it is separated means when the dot containing baseline, it is dipped in the solvent. The solvent containing jar, the solvent means L1 that solvent is that is drawn up the adsorbent layer by capillary action. With the help of capillary action the solvent is slowly moved through the adsorbent layer. Then it separate the component of mixture along with the solvent. That the mixture, the component in the mixture, what are the components means red color, purple color, blue color. Just for example only we showed here so that is moved with the help of solvent in the thin layer chromatography with a different distance. You see that in the plate from the baseline the mixture containing that compound, what are the compound here, red color, purple color, blue color, it moves in the plate with the help of solvent in different places. So solvent it also moves in a particular place. The red color place it is moved with help of solvent from the baseline as a 2 centimeter, just for example. And purple, it moves with the help of solvent from the baseline 6 centimeter, and blue it 8 centimeter, and solvent from the baseline without the compound just it moves 10 centimeter in the chromatography plate. Now we get the some data here. With the help of data we have to find out the redundancy factor. RF, what is RF means? Redundancy factor. Redundancy factor formula: distance moved by the substance from the baseline. Substance means red, purple or blue, any one. Then distance moved by the solvent means the solvent we are taking noma without the substance, solvent alone moved. That distance we have to measure. So here how many distance it moved solvent alone means 10 centimeter. For example, for redundancy factor for red color I have to calculate means the red color substance it moved 2 centimeter. Then solvent alone moved 10 centimeter. So redundancy factor for red color is 2 divided by 10. So we get 1 by 5 or we get 0.5. That is the redundancy factor. So suppose the redundancy factor like this 0.5 we get means the red color compound, what is the compound? Or they already checked the redundancy factor. Through that chart we can find out what is the red color compound, what is the purple color compound, what is the blue color compound. So thin layer chromatography not only used for purification but also to identify the elements that is present in the mixture. And then suppose the colorless compound that is also present in the mixture means that can be viewed with the help of ultraviolet light or using the iodine crystals or by using any other suitable reagent. Partition chromatography. Paper chromatography is the example for the partition chromatography. We already learned the thin layer chromatography. The same technique only we are going to use here. In thin layer chromatography we have to prepare the thin layer chromatography, but here paper only act as a strip of paper only act as a like a thin layer chromatography. It is the paper only the adsorbent, that is stationary phase. For this purpose we are going to use a special quality paper as a chromatography paper. Then we have to place the chromatography paper after fixing the mixture from the baseline in a particular place. See the first diagram. In that one first picture, in that one the paper one dot is present norma, that is that dot is a mixture of compound. Then the paper now it is placed in the jar containing the solvent. What will happen? The solvent slowly moves through the paper. Why the solvent is moved through the paper? Because of capillary action. Because of capillary action, the paper, that the solvent is moved through the paper slowly. When it reaches the mixture component also moves with the solvent, so that slowly that mixture is now separated. You see that in third picture the component, whatever component present in the mixture is, it is separated. How we can conclude that means on seeing the color, the color difference will be arises. From that only we can find that the elements are separated. So suppose some colorless compound is present means with the help of ultraviolet light or any other suitable spray reagent we can view the colorless compound. So it is like a thin layer chromatography only. The paper chromatography is the same as thin layer chromatography. What is the difference means here we are using paper, that is we have to prepare the thin layer we have to with the help of glass plate only it is supported